This would be the main product. Now, actually, this is usually not what you want, but sometimes maybe you do want this. So this might be something you'd want to use on your cell phone too. In particular, we haven't really seen any ways to add hydrogens to atoms before, right? So if you really did want to add a hydrogen, this is the way to do it. Okay. If you really did want to add a hydrogen, this is the way to do it. This is, again, something that you might have to see here. So now we have two things we can do with the Grignard. One thing you can do with the Grignard is add a new carbon, add more carbons to a carbonyl. This is the main thing. The main thing you do with the Grignard is add more carbons to a carbonyl. However, sometimes what you can do with the Grignard is just protonate it. And that just adds another proton to it. But if you don't want to protonate the Grignard, you have to keep it away. You have to keep it away from basically protic solvents. You have to keep it away from protic solvents because they would protonate the Grignard, or from acid. Okay. All right, so again, these are some important ideas for us. Okay, so can I erase this now? So let's say we took this and we added these two things in sequence. What would we get?
Is the RCH3CH2?
Could be any alkyl group. Any alkyl group.
What are we adding?
Adding it to this.
Well, you'll get R connected to C with 2CH2 connected to it 1L and only one bond.
So this would be the reaction?
Mm-hmm. And then the O would get protonated.
So after step 1, we would have this.
Mm-hmm.
And then when we add the H3O+, we would have this.
Yep.
Let's write that over here. All right, so what we just saw is that we can take this aldehyde, and if we add R minus, we would get this. We've added, so we've just added an R to this carbon down here. That's just the reaction we just went through over here. Okay. So let's see, this is interesting because notice here we started with kind of a methyl carbon. But now this is a primary carbon. So we started with methyl alcohol, and now we have a primary alcohol. So we're making something more complicated. That's what excites synthetic chemists, when they can make more complicated things out of simple things. So now we've learned how to make a more complicated alcohol from a less complicated alcohol. So this would be a good synthesis problem.
Same alcohol.
These two? So this alcohol has 3 hydrogens.
An R on the left, not an E.
Yeah. Where did this R come from? It came from the Grignard.
Yeah. Okay.
Notice what actually happened here. There used to be a hydrogen over here. But then we did an oxidation. And remember that oxidation removed that hydrogen. And then we replaced the hydrogen with the R when we did this reduction over here. Now we ended up with an alcohol, but now we have an alcohol with a carbon chain instead of a hydrogen in this position. Where did this R minus come from? Well, it came from a Grignard or an alkylithium. Grignards and alkylithiums are our sources for R minus.
So we did that and then we protonated it too, right?
Yeah, you'd have to protonate it too. I didn't include that, but we'd have to do that as well. That's right. So here I showed the steps in more detail. Okay. How could I get this now? Would this be going from here to here, an oxidation or a reduction?
Oxidation. No, because you're making more bonds.
So now the carbon has 1 bond to oxygen, and here we have 2 bonds to oxygen. This is the oxidized side of the board over here. So this would be oxidation again. Now we made another aldehyde. Here we have another aldehyde over here, but we started with an aldehyde with 2 hydrogens, and now we have an aldehyde with a hydrogen and a carbon chain, a more complicated aldehyde.
In order to get that, we have to deprotonate it, right?
That's right. But
So
just
you
what
have to
reagent
add
would we use here?
A base.
What reagent do we use
PCC.
here? PCC.
Oh, right.
Just use PCC, and we're not going to go through the mechanism for that.
Wait,
We just add
how do we
PCC.
know to use PCC?
Because we simply have memorized that PCC oxidizes alcohols into aldehydes. We just have that memorized. That's one reaction we're not going to learn the mechanism for. So we should just memorize that.
Like in OChem, we're not going to?
Right. Okay. So that would give us this. All right, so notice that we started with a methyl carbon, and we got a primary carbon now. But let's say we're still not satisfied. Let's say that we want to make this into a secondary carbon. How can we add another carbon chain?
You add another Grignard or
Alkylithium.
Yeah.
That's right. So we need another source of R minus. Again, the R minus could come from a Grignard or an alkylithium again. And then that would give us this. So this has 1 R and 1 H, and now it has 2 R's and an H. We just added this other R in here. Again, you could go through the mechanism for this. We've just seen that mechanism a couple of times, how the R minus comes in and attacks over here. And then you protonate the oxygen, which gives you this. So again, in the second step, we have to add the H3O plus to get this.
The reason you can't just add like CrO3 is because it's now a primary carbon and not a methyl carbon.
Well, the problem with these is, remember, these over-oxidize you.
Oh, right.
These would take us all the way to a carboxylic acid. So we could draw that in here. I didn't leave myself room, unfortunately. But let's say we had taken this guy, I'm running out of room, but let's say we had used, say, potassium Cr2O7 or CrO3. That would over-oxidize us all the way to a carboxylic acid, which is usually not what we want at this part of the course. So if we had put in these reagents here, we would over-oxidize. So PCC is the safer thing to use at this point. Okay, so let's try to finish up with what we were talking about here. Okay, so again, basically, you kind of want to avoid these reagents because they tend to over-oxidize. Safer to use PCC over here. In order to make my board cleaner, I'm just going to erase this, I think, right now. But in general, these reagents tend to take us all the way over here. What type of alcohol is this? Primary, secondary, or tertiary?
Primary.
Because it's got 1 carbon chain. What type of alcohol is this?
Secondary.
And we started with a methyl alcohol, so we keep getting more and more complicated over here. Well, the logical thing to do now is to turn this into a carbonyl again. So the logical thing is to turn this into a carbonyl again. What reagent would we use here?
PCC.
PCC is always safest.
I mean, I guess we could just.
PCC is the safest thing to use at this point. Okay, now actually, let's talk about something else here. What does it take to oxidize things? Notice that every time we oxidize, remember that oxidation means losing a hydrogen, right?
Mm-hmm.
Every time we oxidize, we're breaking a carbon-hydrogen bond. Every time we oxidize, we're breaking a carbon-hydrogen bond. For example, here, we broke this carbon-hydrogen bond to get to here. And then when we over-oxidized, we broke this carbon-hydrogen bond to get to here. Or here, we broke this carbon-hydrogen bond to get to this. And then if we were going to over-oxidize that, if it was going to over-oxidize, we would break this carbon-hydrogen bond to get to this. Okay? When we oxidized this, we broke this carbon-hydrogen bond, and that gave us this. Therefore, we do not need to worry that this will over-oxidize.
Because there's nothing else that it can take.
Yeah, this can't over-oxidize because it has no more carbon-hydrogen bonds. Therefore, it's safe now to use these reagents. It's now safe to use these reagents. We don't need to worry about over-oxidizing because there's no more carbon-hydrogen bonds to break down here. So we could also use, so we can use basically any of our oxidizing reagents. Any reagents here would work. So primary alcohols can over-oxidize, but secondary alcohols can't. And we can see that they can't because they run out of carbon-hydrogen bonds. So they can't over-oxidize at this point. So we can use any of these reagents. Again, if you're coming up with reagents on your own, it's always safest to use PCC. But you need to know what to do if they give you the reagents. If they give you the reagents for a methyl or a primary, it's going to over-oxidize to a carboxylic acid. But if they give you the reagents for a secondary, it's going to stop here.